In this video, we're going to continue our efforts to get a taste of Inventor using the Lego project. In a previous video, I created the part Lego 1, which was the 1x1 Lego without a cavity in the back to allow it to mate with another Lego. I want to make a new Lego, which is similar to the one I just made, but this one will have a cavity in the back to accommodate another Lego. So the very first thing I'm going to do when I work on an Inventor project is, of course, log into the computer first. Then I'm going to open School Loop and see what I have to do. So typically all assignments will be on School Loop, so you'll want to open those up. There'll be PDFs attached to the School Loop assignment. In the School Loop assignment itself, there'll be content that's important to know, so you'll want to have those up and in tabs that you can Alt-Tab to very quickly. So you want to keep all relevant documents open in a separate tab, as there may be multiple documents that you'll need to refer to, as I just said. So we're going to launch Inventor, and then we'll want to set up the project. This is the big one. So I've already launched Inventor. And this is a screen which kind of allows me to see what's going on. I'm going to just close it, and I'm going to have this picture here. And the very first thing I want to do is click Project, and you can see that I only have the default project and the interactive tutorials, which are projects that come with Inventor. You'll recall in the previous video that I already set up the Inventor project, but where is it? Well, when you log off, the computer will change. Inventor will no longer look at your profile. So what you need to do, it's very easy. You're going to browse to that Inventor project file that I referred to earlier. It may have been unclear what that project file was for, but now we're going to find out why. So I'm going to browse, go to Computer, go to my Z drive, Inventor folder. There's my Lego project folder. And now I'm going to select that Inventor project file, IPJ. And as I just showed you, I set up the project for Lego. We're okay there. So I'm going to go to the I and hit New. The reason I do that is because it brings up this Create New File menu. If I just, for example, there's some shortcuts right here. I can say New Part, like that. And in fact, I do use that a lot. However, that automatically puts me into the default template, which is in inches. I can go Big I and go New, and that brings that up. Or I can go Big I, hover over New, and just say New here, and it brings it up as well. So as I mentioned before, standard.ipt is the English units. We want to go to metric and choose standard millimeter metric, create. And here is our workspace. First thing we always do in Inventor is we make a 2D sketch. And I'm going to choose the XY plane, so I'm going to click anywhere on that plane, and there it is. And say you wanted to have some grid marks here, it's up to you. You can come to the Big I options, and then go to Sketch, click Grid Line, Apply, Close, and there are some grid lines. They're each of 1/8 of an inch in size. So first thing I'm going to do is make my rectangle. And I'm going to, instead of putting in the numbers here where it's blue, that's prompting me to put a number there, then I can hit Tab and that'll take me over to the other one, like that. I'm just going to leave it like this and left click, right click, OK. And what you see is 2 blue lines and 2 green lines. Green lines mean that the system is not constrained. So if you look down here in the lower right hand corner, you'll see 2 dimensions needed to fully constrain your sketch. And you always want to have a fully constrained sketch whenever possible. So to do that, I'm going to come up to the constrain panel here. And this is the general dimension constraining tool. And I'm just going to click on there, and I'm going to make that equal to 8. And you can see that now I only have one green unconstrained edge. That means that this thing can go up and down. I can even come down here and show the degrees of freedom by, I think, by clicking this button. And you can see that that one can go up and down like so. And so I can turn that off by doing that. And so what I'm going to do is I'm going to make it a little bigger, but I'm going to use the general dimension tool, come out over here, pull out, and make that equal to 8. Right click, OK. And now I've got a fully constrained square. It's blue, that tells me that, and then also down here in the lower right it says fully constrained. So I'm going to finish that sketch, and I'm going to extrude upward 9.6 millimeters just as before. And I've got a rectangular prism which forms the basis of my Lego. I'm going to hit the home button up here next to the view cube, and that just orients it in a way which makes it convenient to do the next step. So again, I'm going to place a sketch plane right here on top, and I'm going to use the circle to make that stud. And again, I'm just going to plop it down anywhere. I don't care where the center is or the diameter. And so I have green everywhere, and indeed down here in the lower right it says 3 dimensions needed to fully constrain this circle. So I want to use the general dimension and go here to here, and I believe that's going to be 4, right? Half of 8, because we want to center that. And so from here to here, that's also going to be 4. Well, actually, that one's already constrained, so I want to go from here to here. Let's see. Let's escape. So how about here to here? That's the one I want, and that's going to be 4 as well. So now we've got it centered, we've got it located. So located has a special meaning. The size is not correct for this feature, but at least it's located on the part in the correct spot. And now to get rid of this other one dimension that's unconstrained, I'm going to use the general dimension tab button as well. Again, I'm just going to click on my circle, pull out, and write down the diameter of that, which is 4.8. And now everything is nice and blue, so things are fully constrained. And so let's finish that sketch. And I'm going to back out a little bit. I'm going to extrude there. And I like to have this open, so sometimes it comes out not quite open. And you can see how I opened it up. And we don't want to go up 9.6. I believe it was 1.8. So that's basically the identical Lego as we made before. I'm going to come up here and I'm going to give it a distinct color to distinguish it from the first one. I'm going to go with smooth light orange. There it is. So I'm going to save it now. Even though it's not completely finished, you should save early and often. So last name, first name, underscore Lego2. Save. And let's just make sure it's saved in the right spot. So go to my Z drive. Under Inventor folder, there's my project folder for Lego. And there are my 2 pieces. The one I made earlier and the one I just made. Now, I'm going to add to Lego2 right now. So I'm going to come over here and I'm going to go to the free orbit button. Click there, and that allows me to turn it in this direction. Right click OK. And I'm going to make a sketch plane on the bottom here. So what I want to do is make a square here, which is will accommodate that round stud that's on the other end. Right, so if I kind of move this around, there's the stud, and the stud on another Lego is going to go into this rectangular hole. Now you saw the circle on the other side get projected up here. That occasionally will happen. That can be useful at times if we want to project geometry. But here I just want to make sure that I get this thing the right size. So size-wise, I think we'll all agree that it's 4.8. So it's on a side, it's the same as the diameter of the stud. Now what I need to do is center it. And you can see I have two more dimensions left, the X and Y centering or locating of this object. Now I could project this geometry up here and try to make it coincide, but I'm going to use another tool. I'm going to go from here to here, that distance. Well, that distance is going to be half 0.5, whoops, 0.5 times the difference between the whole length, which is 8 millimeters, minus the distance of the square, which is 4.8. And my expression turns black, which means that it's okay. No syntax errors, so I'm going to say okay. And that centers it. So again, 1/2 the difference between this and this is going to give me the correct distance there. And I'm going to have to do the same thing for this guy over to here. That is going to be 0.5 times 8 minus 4.8. So this shows you that you can put expressions into these dimensions, and you can see that it's now all blue, and down in the lower right I'm fully constrained. So right click OK. Finish the sketch. I'm going to extrude inward, and I'm going to make it 2 millimeters. So give it 0.2 millimeters headroom, so to speak, for the stud on the other one, and OK. And I believe that that is the final form of the Lego number 2. So let me then save that. We're good there. Okay, now I'm very quickly going to I'm going to include the assembly part into this one as well. So I'm going to go Big I, New, and I want to go down here to Assembly. So these are parts, these are assemblies, these are drawings, and these are presentations. We'll learn about each of those very soon. So I'm going to go to Metric, and I'm going to choose the standard assembly in millimeters right there. Create. And you'll see that this looks different. It says place. Well, it's telling me to place parts into my assembly. So left click, right click, OK. So there's my part, first part, Lego 1, and I'm going to place in there Lego 2 as well. Left click, right click, OK. And now, just as a part file, which has an extension .ipt, consists of a single part with a bunch of geometry defined by you, an assembly consists of multiple parts that you put together, you assemble using constraints. Now, if I use the free orbit tool here, it kind of moves everything. So what I want to do is find a way to move these individually, and there's a cool way to do that, or an easy way. So if you go up to the position panel here, you have free move and free rotate. What I want to do is take the orange one and move it over here to the top of the green one, because I want them to interface. So I'm going to click on it, and then I'm going to hover over free move, and you'll see that it says V is the shortcut. So if I type V, this will allow me to move this guy individually, and I'll hit escape there to end that. Now there's also one, if I click on that guy and I hit free rotate, you'll see that if I hover over free rotate, well anyway, it allows me to rotate this guy individually. Let me do a right click OK or an escape. Now if I hover over free rotate, you'll see that the G is the shortcut. So I am going to take this one, click on it, hit G on the keyboard, and I can rotate this guy just a little bit like that. So that's exactly where I want it. Right click, OK. Now, here's the most of the business in the assembly file is using the constraint button on the relationships panel. So I'm going to hit constrain, and you'll see there are multiple types of constraints. There's mate, angle, tangent, insert, and symmetry. We're going to use the mate constraint. There are two different types. There's this one here, which the picture kind of shows. We're going to use that one right now. It's where the two pieces just go against each other. coming from opposite directions. And then there's the flush here, which causes two surfaces to be parallel. We're going to use first this one, and I'll show you how that's done right now. So I'm going to click on this face, and you kind of see an arrow pointing out, and then I'm going to do it to here, and it pops. And so what I've got here is two parts that are constrained so that those planes can never get away from each other. Well, that doesn't help us too much, but it gets us started. What we can do now is come up here to the constraint panel and use flush instead. So I'm going to make that parallel to that, apply, cancel, and now you can see that I've removed a degree of freedom and it can only move in this direction. So you might expect now that the final constraining maneuver will be a flush between these pieces here, apply, cancel, okay. So we've just assembled in CAD our Legos. Now, one thing we want to check on is basically how it looks. And what I can do is I can come over here into the browser, which is the white area here, and I can double click on this mate constraint and I can change it to 5, and that'll put an offset on there. So this may be useful to see, okay, how it looks. Yeah, it looks right. It looks like it goes in the hole, just like a regular Lego. And so there we have it. So I'm going to undo that and make that 0 again. Now what I'm going to do is take one of the flush constraints and I'm going to offset that by 2. And you can see what happens is that they are no longer put together correctly. I'm actually going to change that to only 1 millimeter, so it's not so obvious. Now you might ask, okay, is this possible? Can I assemble these two this way? One way to find out is to go up to the Inspect tab and then Analyze Interference. So you click that one, and then OK. And what it shows you is that you've got this volume in here that where the green and the orange attempt to occupy the same point in space. It's a little chunk here, as you can imagine what it would look like. And it tells you the volume of about 5 cubic millimeters interference. Okay, so that's very useful to understand that. So I'm going to go back and change that back to 0, and this will be my assembly file. So to save that, I'm going to hit save, and then I'm going to put my last name, first name, underscore Lego assembly, and I'm going to save it. And you can see that I have all my files here in my project folder.